So the second example is going to have us both work backwards and approximate at the same time, meaning that, again, like we did in the previous section, we're going to try to find theta between 0 and 90, including 0 and excluding 90. That makes each one of these to 6 decimal places true. So what we actually want to do with this is try to solve for theta, right? But unlike our algebra techniques and rules, we cannot just take this and say that it's multiplying and divide both sides by tangent to get theta by itself. This is a function. And so in order to get rid of it, we have to introduce something that you also should hopefully remember from your algebra classes, and that is the inverse. The inverse in math is the fancy term for reverse. Normally, we are given an angle to input, just like the previous example, and we give them out that ratio, whether it's in fraction or decimal form. So what we want to do is then take the inverse of the input and the output. We want to reverse these two things so that I now have the tangent of 6.43588841, that number, that ratio that we've been given them, the 1/2s, the root 3/2s, the root 2/2s. And we want to now switch and reverse the input and the output to get our theta by itself. Now, obviously, I can't just switch those and keep tangent because it's not the same. This right now does not represent an angle. Theta was our angle. So I don't know if you guys remember, but the symbol we use for inverse is that -1 exponent. And I know that's not the best thing because it also means to do the reciprocal. When we were dealing with fractions, for example, that meant 1 over x. When we're dealing with the inverse, that's not what it means, okay? But we will use that -1 to denote that, you know what, we actually reversed the input and the output. And so as long as you have that knowledge and you can apply that in your calculator, then we'll be able to solve for theta. All we got to do is punch this into our calculator now. So I'll do that so you guys can see what it looks like. Now it's usually the inverse that we're looking for, and it's going to be typically the same place where our sine, cosine, and tangent buttons are, but right above it in yellow or blue or whatever color your calculator is. So you're going to have to hit the second key and then your trig function to get the inverse tangent. And then we'll have to apply the ratio, the decimal representation of it that they gave us. So for us, it was 6.4358841. And when we hit the equal sign, notice it's given us the angle. Now you have to recognize that 81 point whatever is our angle measurement. And so since they asked us to give them the decimal degrees to 6 decimal places, because that's what they gave us was 6 decimal places, then we have to give them that angle. And because they wanted it to 6 decimal places, remember, we're going to have to look at one more to see what we do here. And so therefore, our final answer would be 81.168073 degrees. Not bad, really simple, not a whole lot other than making sure that you know how to use your calculator. So if you want to try and challenge yourself, try part B, go ahead and pause it right here. Otherwise, I'll go over it with you. This one is a little bit trickier, I will admit. All right, so why is this one a little trickier? If you looked at your calculator to try to see where secant theta was so that you can then take the inverse and flip-flop your input and output to rewrite it as secant of some number equals our theta, you'd have to put the -1 not after the number, but after the trig function that you're actually reversing the inverse of. But notice, when you go to your trusty calculator, it only has the big three, sine, cosine, and tangent. So unfortunately, that means that we have to take this and rewrite it in its alternate form. And if you remember, for secant, reading right to left, that was the reciprocal function for cosine. And remember, for cosine, if we're going to take the number that they gave us and change it, do the reciprocal, then we would have 1 over secant theta on that side equals 1 over that big old long nasty decimal that they gave us. But that then allows me to rewrite this as cosine theta by definition, and unfortunately it is still equal to this though, 1 over the 1.16. So not only do I have to do the reciprocal, then I'm going to have to take this and find the angle by doing the inverse. So remember, when you're trying to find the angle, you have to do the inverse, which means we will have to go ahead and take this input and output and reverse their order by doing a little thing called the inverse of 1 over 1.160629. And that will then equal my theta. So that's what I'll have to go and punch into my calculator. Do that carefully. See if you get this answer of 30.502748 degrees. So these are definitely the most difficult because not only did we have to do the reciprocal flipping of both the left side of our equation and the right side, we also then had to take that and do the inverse, where we do the reverse of our input and output to get our theta by itself. So be careful with those. They can be a little bit more challenging and confusing because we're both flipping the ratio and then the input and output, domain and range, if you will. Example 3, a little bit more straightforward. They just want us to figure out if it's true or false using our calculator. Now notice on part A here, the cosine of 70 is not something that we know as a reference angle, so we're going to need a calculator approximation. So punching that in our calculator, we get, and then doing the carefully. I advise you guys never to leave the squared where they put it. I would put it at the end so you don't make a mistake. Remember, it's the trig function that we're squaring. Okay, that's why they put it after the trig function. We're not squaring the 35. So you need to put those parentheses, but my advice is to move it on the outside. So we're actually going to have to do 2 times the cosine of 35 squared minus 1. So I'm next going to have to find the cosine of 35, which some of you may recognize as just half of 70. But watch, it will not just be half of that value. You should have gotten, notice it is definitely not half. Okay, so when multiplying all of this out on the right side, our question is it equal to that thing on the left side, the 342020? So first I'd have to do my order of operations and square that value first, then multiply it by 2, then subtract the 1 last. And my question is, does it give me the same value? And go ahead and do that and see what you get. And you should have gotten the same thing so that you know that is indeed a true statement. All right. So go ahead and pause it right here. Try part B and C. You should already have a hunch on whether or not this is true or false. If you really take a look at it, we already did a problem like this previously, but with sine. So answer this before you actually do it. What do you think? Is this true or false? Hopefully you said false. because remember, even though it appears like this side looks like we just distributed, we cannot distribute a trig function. So again, I'm trying to hit that point home. Yes, we're going to use a lot of algebra in this class that we've learned in the past, but all of the rules do not apply to trig functions. So what we would do here is find that value, because I do know that 30 plus 20 degrees is 50 degrees, and then we'll find those two values and then compare. So do that now. And if you got those values, you can definitely see right then and there, without even finishing, that these two added together are much larger than that one. So it is not true and therefore false. Okay, so again, just making sure that we know how to use our calculator in a couple different versions of these examples. So let's do one more, and hopefully that will be enough for you to start practicing on your own for the assignment. So this fourth and final example is a word type problem, and I know it seems like it's very different, unlike anything that you've ever done, but it's pretty straightforward because they simply give us the formula that we should be utilizing for this. So I'm just going to take this formula and I'm going to have to extract of those three unknowns, F, W, and theta. They're going to have to tell us two. So it says to find the grade resistance to the nearest 10 pounds. That's key. They want us to round. For a 2,400 pound car traveling on a negative 2.4 degree downhill grade. Downhill was kind of obvious because it's negative, right? So if we were to draw this, it may or may not help us. In this case, I'm not going to, because they tell me to just use this formula. So I'm going to do that. F equals W times the sine of theta. And without even knowing much of this background, I can pretty much already tell what F probably stands for based off of reading this. Or if you have any physics history, F typically means force. W in this case, of the two things that they gave me that I can actually use, is a 2,400 pound car and a negative 2.4 degree downhill grade. And if I'm guessing the 2,400 pounds, that's probably what W stands for. The weight. The negative 2.4 degrees, the degrees tells me that that is an angle. So it's already set up to find F, which probably represents the grade resistance. So since that's what they wanted me to find, beautiful. All I have to do is plug those two values in and figure out what their product is. So W was 2,400 pounds, and the angle, which happened to be downhill, so negative 2.4 degrees. So punching that into my calculator, I get negative 0.041876, just rounding it. And then I'm going to take that and I'm going to have to multiply that by the 2,400 to get my final answer we're calling the grade resistance. Now please remember that they did ask us to round to the nearest 10 pounds, which, remember, for 10 pounds, that would be that digit. So we'd have to look one to the right of it to see what we do here. So my answer would simply be negative 100 pounds of force. Okay, so not all our word problems will be this peculiar and some random formula, but this is one application of a trig function that I wanted to show you. Okay, short and sweet, guys. That's it. Not much to this section other than making sure that you know how to use your calculator correctly. And before you start, if you're getting wrong answers, make sure that you go back and find out if your calculator is in degrees and not RAD or GRAD, radians or gradients. Okay, it has to be DEG in order to get these correct. In chapter 3, we'll actually learn how to rework these a little bit differently using a thing called radian measurement for our angles. All right, been a good one. Hopefully you understand how simple and easy this can be, approximating our angles and values using a calculator. Just be very careful with the inverse. Make sure that you are knowing when to use that versus the reciprocal. You guys have a great one. Until the next time.